Hello everyone, this is Reshma from Edureka and welcome to this live session on Hadoop. So let's get started with this live session. So we will discuss a few interesting use cases of big data that is solved using Hadoop. So now let us take a look at what this live session is going to cover. So at first we'll start by taking a brief look at what is Hadoop. Then we'll see what are the different tools that comprises the Hadoop ecosystem. We'll take a look at different Hadoop use cases, and that is what this entire live session is going to be about. And finally, I'll show you a demo of one of these use cases using PIG. So let us start by learning what is Hadoop. So we are all aware of all the problems that are associated with big data, be it huge volume, the kind of data that we are dealing with, structured, unstructured, semi-structured, and they are coming at an accelerating rate. So Hadoop was the technology that came up with the solution. So it provided us with two things. First is the distributed storage to store big data, which is known as HDFS, and parallel processing of the data using Yarn. So Hadoop is a framework that allows us to store and process large data sets in parallel and distributed form. So this is what entirely Hadoop is. And the best thing about Hadoop is that it can integrate different tools together to process the data better. And as time goes by, the requirements are increased and the demand of better and faster processing also increase. And there are new tools coming up very frequently that allow us to do that, and you can all use them all together or few of them once in order to enhance your performance. So let us take a look at those tools that make up the Hadoop ecosystem. So these are the various tools that are used extensively nowadays with Hadoop. So I've already told you about HDFS and Yarn. HDFS is the storage unit of Hadoop and Yarn is the processing unit. So similarly, MapReduce is nothing but the older version of Yarn that is also used for parallel processing of data. Then we have got Hive and Drill for analytical SQL on Hadoop, and we've got Apache Spark, which is now the most popular tool that is used for real-time processing of data. We have got PIG for scripting. We have got HBase, which is a NoSQL database. We have got Zookeeper and Ambari, which is used for management and coordination, Uzi for scheduling, Solar and Lucent for searching and indexing. We've got Mahout and Spark MLlib. So these are nothing but they are libraries that contains machine learning algorithms. We've got Kafka and Apache Storm. Now Apache Storm also handles real-time processing, and it is highly optimized on only processing real-time data. Now as I have already told you that Spark also processes real-time data, but it is also capable of doing batch processing. But Apache Storm is highly optimized on only handling real-time data, and Kafka can be used for scheduling those real-time processes. Then for ingesting data, we have got Flume and Scoop. So Scoop is used to ingest structured data, and Flume is used to ingest semi-structured or unstructured data, that is live data coming from social media, etc. So if you can also see the icons there, those are all social media icons. So it definitely handles live data coming from social media. And nowadays social media analytics is very, very useful. Now let us move on to the use cases that you've been waiting. So here are some pretty interesting use cases. So we'll be seeing how Netflix works with Spark in order to generate recommendations for you. We've got TripAdvisor, which uses Apache Spark to manage reviews using natural language processing. And then finally, we'll do IC tweet analysis, we'll do some sentiment analysis, network analysis to find out who are the most prominent people who are tweeting about this particular topic, terrorism and stuff. So let us move on to the first use case, which is the Netflix use case. So I'm pretty sure that you all love to Netflix and chill on weekends, and obviously Netflix has got pretty good shows. So if you have noticed that you get a lot of recommendations from Netflix, and surprisingly those are the shows that you like, and you end up liking those shows. So 80% of the views that Netflix gets, they come from the recommendations. And these recommendations are driven by machine learning algorithms. And they do a continuous A/B testing in order to enhance their performance. So A/B testing is nothing but A/B testing is just to compare two versions of a web page to see which one performs better. So basically you compare two web pages by showing the two variants, let's say A and B, to similar visitors at the same time. And the one that gets the better conversion rate wins. So they do it continuously in order to find out which is going to be the best. And this is how powerful the recommendation engine is. But the main power of which the recommendation engine runs on is Spark. So here in Netflix they use Spark transformers, and if you remember the movie Transformers, so you know that the center of all energy was the Allspark, which is this particular cuboid in front of your screen. So basically even Netflix is powered up with Spark, not maybe this Allspark, but by a Spark transformer. So Netflix basically uses an item transformer. Now, items are nothing but they are elements to be trained on or scored or ranked on, like videos, search entities, etc. So the item transformer extends the Spark ML transformer, and it accepts DMC12 data frame with contextual information. So DMC12 is nothing but it's a DeLorean, a kind of data format. And data frame, you already know what that is. It is a data set that is organized into named columns, like a table in a relational database, or also it is very much similar to a data frame that you use in Python. And it transforms data frames at an item level. So that is why your recommendations are more precise. So this is how Netflix uses Apache Spark transformer, and they use certain processes. So they use data frames. Now why data frames? Because they have observed that by using data frames, they can actually perform the speed 4 times better. So during feature generation, by migrating from an RDD based implementation to data frame, they have seen extensive, very good results, which is 4 times faster. So that's why they are using data frames instead of RDDs. So next, they are also using multi-threading model training. So for single machine multi-threading algorithms, we allocate one task to one machine, and multiple tasks are running on Spark for different parameters. And also the broadcast in Spark has its data size limitations, so they write into HDFS and then stream the data into trainers that are in executors which are running on a single multi-threading algorithms. Then there is also distributed model training. So they use Spark MLlib algorithms and also their in-house machine learning implementations. So they are innovating every day. So the interface is kept similar for both multi-threading and distributed algorithms, so experimenters can try different ideas very easily. So this is a very flexible system, and they are innovating every day. So that is why Netflix is so popular, and we all love to Netflix and chill, right? So now let us move on to the TripAdvisor use case. I'm pretty sure that every time you booked a holiday, you must have visited TripAdvisor at least once just to find out that whether the hotel that you are going to book or you have booked is good or not, what are the attractions of the places that you're going to visit, and what are the good restaurants, some good food, where can you get good food around the places. So TripAdvisor gives you all the reviews, and it covers almost all parts of the world, and it is one of the best platforms for hotel reviews. But the problem was that the TripAdvisor, even they cover the entire world, there are still some places that might be unexplored because they completely rely on user reviews. And sometimes we as users, I don't want to always write a review because maybe I'm in a hurry or I'm too lazy or something like that. So they have to find a solution for that, right? So how do you get around these problems? It turns out that when you have a very awesome user base like TripAdvisor, you can just ask them. So for a while now, they have been asking simple yes or no questions, which are known as tags. But sometimes users also do not answer to that. So for that, they have been working on a possible solution that is known as auto-tagging. So you can simply ask a reviewer one of those tagging questions, whether you're not sure of an answer, but that would just waste their time and limit the coverage of the results. So what they did is that they solved this problem using a semi-supervised form of logistic regression to perform the auto-tagging. So a large portion of the model consists of a bag of words, a type features from user that is submitted reviews on different properties. And since it is a semi-supervised technique, so they not only get the reviews on locations that have already the tag votes, but also a large chunk of unlabeled data. So they use Spark in order to power this algorithm. And Spark is an excellent data parallel engine that allows to spread your data among all the nodes in your cluster. So given Spark is a base, it is pretty straightforward process working with this data. So we just read the reviews in the memory spread across a bunch of nodes in the cluster and iteratively work on one tag at a time. So the large chunk of the time takes to read and process the reviews to a usable format, but the good part is that you just have to do it once when in the beginning of the process, so you don't have to repeat it. So the entire process of performing auto-tagging is broken down into 3 stages. So the first stage or the first step is to generate data or the data set generation. So what happens here is that all the reviews are read from all locations, whether it's a restaurant, hotel, attractions that have votes on them, and they generate a data set for each tag. So this consists of a feature selection, creating the feature vectors and choosing the cross-validation sets. The next step is training. So for each tag, you have to profile the regularization parameter to train the model. And this is an embarrassingly parallel stage that is done pretty straightforwardly with Spark's parallelize operation. So what you do is that you just broadcast the data set to each of the node and parallelize. I'm so sorry, I've been pronouncing it wrong. So the parameters that you want to profile. And each task simply returns the out of the sample error estimate that is used to select the model. Next is application. So this is just to read all the reviews into memory. And yes, all of them. So it iteratively score each tag on each location, dumping the results into HDFS, and import this into Hive with load data, which is basically a quick HDFS rename operation. So this is all done remarkably efficiently. So this is how TripAdvisor handles all their reviews, and they always want to keep it authentic. Even they are auto-tagging, the algorithms that they're using are pretty accurate, and they can predict what you like and what you'll not like. So this is the power of analytics. They know it even if you don't tell them. Now let us take a look at the ISIS use case. So there have been a lot of tweets in Twitter. So there are ISIS fanboys, whether they are fake or not, we don't know that. And they are like they are making tweets, or they're tweeting like pretty violent content, something like this. And then, so we want to know, I want to do some analysis on this. So there are a few things that we want to find out. All right? So these are the goals by which we want to understand, or which we want to process to understand this. So first we'll perform a social network cluster analysis. So this is just to find out who are the major players in the pro-ISIS Twitter network. So ideally we'd like this to visualize this by a cluster network with the biggest influencers scale larger than the smaller influencers. So we want to find out that who are the people that are influencing others, which are the ones that are getting the most number of retweets. So we want to keep them in a bigger scale just to find out who are the most influential ones. Then we'll do a keyword analysis. So we want to find out that which are the keywords that are derived from the name, username, description, location, and tweet, which were the most commonly used words by the ISIS fanboys. So there are some words like Bakia, Dabik, Amak. Now I don't know Arabic, so I don't know what they mean, but these are the most prominent keywords. So we are also going to find out, we'll also try to find out that whether there are other keywords or not. Then we'll do a data categorization of links. So we'll find out that which websites are the pro-ISIS fanboys linking to. So this include mainstream media, alter media, jihadist websites, image upload, video upload, pretty graphic video upload that you never should watch. And then sentiment analysis. So we want to find out whether the tweet is a positive, negative if someone is speaking against the ISIS. So a tweet might contain the word ISIS, right? But they might be speaking against it. So we cannot call them an ISIS fanboy. So that's why sentiment analysis is also necessary, whether to find out whether it's a positive, negative, neutral. And if it is negative, we have to include the reasons why. Then also a timeline review to visualize all the tweets over a timeline and identify the peak moments. So this is all done by using Spark R. Now Spark R allows you to use the R shell. So you're using R because you have been comfortable with R. So you have the liberty of using R but use the processing power of Spark. So this was entirely written on R node using Spark R using the R language. So we have got our data set. The first thing that we need to do is to dump the data set into HDFS and then use Spark R to perform some transformations, filtrations, and process it. So in order to process it, you have to do some initial analysis and filtration. So you can filter out some names. There might be some redundant names, some fake names that are based on the real account. So what you can do is that you can smart out like the columns as character and truncate the usernames to have at most 20 characters in length in order to eliminate like certain anomalous usernames. Then some more filtration could be necessary. Then you create an adjacency matrix to make a better model, and finally like make visualizations using a visualization tool like Zeppelin or any other tool whichever you're comfortable with in order to gain insights, or whatever that you have analyzed you need to visualize it, right? So this is just an overall idea about how this was performed. So maybe in the coming videos I might show you then how they have done that. So we'll move on to our demo since you have waited long enough. So I'm going to show you a travel sector use case. So I already have talked about TripAdvisor. So let's say that you are working in not as a large scale like TripAdvisor, but in a lesser scale, and you want to improve your business. So you might need some analytics, and that is why analytics is necessary, right? To improve yourself, to improve your business, you have to know things. You have to understand the problem, solve it, and then understand and gain insights from that problem. So if I'm like running a travel sector, if I have a travel agency and I want to promote like some destinations so that people can go visit, I can have tie-ups, a lot of blah, but let me just get back to the point. I'm really sorry. So we're going to find out the top 20 frequently traveled destinations. We are going to find out the top 20 locations people travel from. It means we're going to find out the home city. And then top 20 air revenue destinations. So let me just show you. So I'll be using PIG. So I have got a travel data set that basically contains the location from where you're traveling to where you're traveling to. So the airport code basically, and then air price, car price, hotel price, things like that. And then these are the things that we're going to find out, and we're going to use PIG. So I hope that you can all see my screen. So I will wait until I get a heads up because we have been facing this issue. All right, so since you all can see, so thank you for replying. All right, so the first thing that we need to do is that we need to load this file into HDFS. Now I have already done that. So now let me go ahead and start my PIG shell. So this is my PIG shell, and I'm just going to load the data set now. So this is how you load it. So my data set is traveldata.txt. And here are the different column names, and I have mentioned what are the data types of each of the columns, like city pairs is character array, from is your home city, which is a character array, then to is your destination, which is a character array, then there is product, then there is a child, if you have their children traveling with you, then start date, end date, air price, car price, something like that. So this is what your data set basically contains. So I've just mentioned the data type. So now let's go and press enter. Then the next thing that you have to do is you need to find out the top 20 destinations, right? So for that, I have taken a variable called destination, and I'm grouping this. My data set, I've stored everything in travel data, remember? My data set is stored in this variable travel data. And I just want to find out the destination. So I'm keeping the destination. So what I'm doing is I'm filtering out only the destinations, and I'm storing it in this variable destination. So press enter. So the next thing I'm going to do is I'm going to find out the most popular destinations, right? Not all of them. So here I'm storing the popular destination in a variable called popular destination. And for each destination, generate group count travel data. So I want to find out, so how do you decide which is the most popular destination? It means where a lot of people visit. So I will count how many number of times one particular destination has come up. So whoever has the most number of visits from different people is the most popular one, right? Simple logic. So here I'm finding out the popular destination, so I'm keeping a count of all the destinations. Now I'm going to order it. So ordering it basically like in an ascending or descending order. So I want it in a descending order because I want the most frequently visited places. And then I just only want the top 20, right? So I'm going to limit this by 20 values only. So the first thing that we did is we need to load it into the PIG storage, so use this command. So I've already explained to you that I have just used the column names, and I have just written after the colon that what are the data types of each of the column, and I have stored it in a variable called travel data. Then I want the top 20 most popular destinations. So I would just want to filter out the destinations. I don't want to know which was the home city, what was the air price and all. I don't have to do anything with that. So I'm just filtering out the destination. So I'm storing the destinations in a variable called destinations. For that, I'm using a command called group travel data by to, since the name of the column that tells you the destination city here is to. So you can see here 2 is a character array that tells me the destination. So I'm just only filtering out 2. Then I want to find out the popular destination. So in order to do that, I have to find out that which are the places or which are the destinations that the people visit most. So that way something is popular, right? So for that, I'm using this command for each destination, generate group count travel data. So basically I'm counting that how many times a particular place has been visited. And then I want to find out that which was the place that has the maximum visit by tourist. So I'm using a different variable called order destinations, and I'm ordering it by descending order because I want the highest one first. So here $1 is nothing but this is just the positional value. So, and then my problem was that, or my challenge was that I need to find out the top 20. So I don't need all the data or all the destinations. I need just 20. So since I've already ordered it in descending order, it will just take the top 20 values. So here I'm using this command limit order destination 20. So it'll give me only 20 values. And here, when you dump it, or you can store it in a file in HDFS, and finally when you open that file, you can find out all the result is stored there. So basically here the destinations represent airports or the airport code of a particular place. So it'll just show you the top 20 places in descending order, that whichever is the most popular one will be on top. Maybe it's Miami or LA or anything. So basically it's a US data set actually. So the next thing was that which was the place that people mostly travel from, or which was the home city, or where do most of the tourists come from. So here also the first thing that you have to do is you have to load the data, but since you have already done it, we don't need to do it again if we're doing it back to back. So here I want to find out the origin city. So here I will group the data by from. So if you remember, for finding out destinations, we use to, and here we're using from. So from is my home state or home city. And then I want to find out the popular city or the city with the most number of tourists where people travel a lot. So I'm using popular origin as a variable, and here I'm again counting that how many visits are there from each city. And then again I want to find out the top 20. So again I'm ordering it in a descending order, and then I'm limiting it by 20 values only, and again I'm storing it into a different file, result2, and when you just view that file, you can see that it will give you the 50 airport locations or 50 cities where people travel the most, where from people travel the most. So next what you have to do is that you want to find out the place that actually gets the highest revenue from airfares. So again, since I'm finding out the place where people go to and where they earn a lot of air revenues from, so again I have to group it by destination. So I'm using group travel data by to. So I'm storing it in a variable destination. Then I want to find out the most popular places. So for each destination I want to generate groups. So I want to sum the travel data air price as air revenue, then I want to add up the car price and the hotel price, and then I'm just basically doing is that I'm just giving it alias names like air revenue and car revenue and hotel revenue. So there's a total, so whatever the total hotel price was for that place, it is stored in hotel revenue. So then I want to find out the air value destination. So for each popular generate, so again it's it's a positional value $0 as destination and 1 as air revenue. So it'll basically give you the place name and how much revenue they generate by airfare. So again I want the top 20 places. So I will again sort it in descending order and limit it by 20. So when you view it, you'll find out the place and how much revenue generates from airfare. So that was basically what I was going to show you, but alas, I couldn't. So let me just show you where you can get a lot of free stuff to read about Hadoop from Edureka. So we have got our blogs here, so we've got a lot of blogs here, so you can just check it out. You can just go to this link, www.edureka.co/blog/Hadoop-tutorial, and then you'll find the links of the other blogs too. If you want to check out different videos, we have got a playlist for big data and Hadoop videos, so you can find it out in our channel. So we've got a lot of videos. So I have also done a video where I have shown you how to use PIG queries on an Olympic dataset, which is this video, Apache Hadoop tutorial, so you can go and check it out. And then here is the LMS. So if you buy a course from us, this is what your LMS is going to look like. So you'll get whatever is necessary in order for you to learn Hadoop, you'll get here. So all your modules, your class recordings will be here. So class recording 1 and different documentations. You've got quizzes, assignments, some commands, Linux commands, since you'll be working with VMs and Linux. So you'll be working in Linux VM. So if you're not familiar with an environment like that, so you can also get the documentation here. So basically your LMS will cover everything. And hence you have bared with me for so long, despite of all the technical glitches or whatever difficulties that we have faced. I really want to thank you on behalf of Edureka for staying till now. So please fill up this survey form that will help us to improve our content, and also it is beneficial for you and it is like a gift to you since you have bared me and bared us for so long. So fill this form, and if you are thinking of buying a course from Edureka, and if you have like fill this form and submitted it, it will help you to get exclusive discounts on your purchase. So thank you guys for attending this session. So thank you so much, everyone.